Okay, guys, so first thing I wanted to point out is that I re-uploaded the notes from today because I added 2 more diagrams down here. So for the range of exponential, it could be asymptote, comma, infinity for either a types of these 2 graphs, or it's negative infinity, comma, the asymptote for either of these 2 graphs. So just wanted to point that out. And then I'll actually be going over these end behaviors as well because I didn't really like the way I did it in class today. So I'm going to be showing you a different way as well. So on here, this is the first exponential one we're going to do. So I have 2 times 3 to the x and then minus 4. So right away, I know this is an exponential function. So I'm going to change all of those blanks in the first sentence. So I know it's going to be exponential with a horizontal asymptote of y equals blank. And that blank is always that k value in our equation. So for this one, it's going to be negative 4. Okay. The range of the function, I'm looking at what the graph looks like. So it is starting down here and increasing. So if I look at my notes, that matches this diagram. This first one I have drawn. So my range is going to be asymptote, comma, infinity. So it's going to be negative 4, comma, infinity. And looking at my graph, I can tell it is increasing on its domain of negative infinity to positive infinity because all exponential functions have the same domain. The end behavior on the left is as x goes to negative infinity. That's always the same. Where's y going? And the end behavior on the right is as x goes to positive infinity. Where's y going? So in class, I know I told you guys to line it up with the range, and I didn't really like that explanation after I thought about it and I helped some kids out. So for these two, one of them has to have one of the infinity signs, whether it's positive or negative, and then the other one has to have the asymptote. So when you're doing this, you just kind of have to look at the end arrows, just like we do for log ones. So on the left-hand side, you're trying to figure out where is the left arrow going. So if we look up here, the left arrow here, it's really forming an almost perfectly straight line. It doesn't really look like it's going up or that it's going down. So that means it's approaching that asymptote. So that means it's just going to negative 4. It won't ever get below negative 4. So for this one, I'm going to select y goes to negative 4. And then on the right side, if I look up here, my right arrow goes up and up and up forever. So that y is going to positive infinity. So you can see I have one of the y's going to the asymptote and one of them going to infinity. Okay, I'm going to do another exponential. So we can take a look at this one. Negative 2 times 1/3 to the power of x plus 6. So again, I can fill in those first couple blanks right away because I know it's exponential, which means there's a horizontal asymptote of y equals blank. If I look at my equation, my k value is positive 6. So that's my asymptote. For the range, I need to look at the shape of my graph. So I have it going down and then evening out. Down and then evening out. So down, evening out is this graph. So my range is going to be negative infinity, comma, the asymptote. So it will be negative infinity, comma, 6. It is increasing. Okay, I'm going down to up on its domain of negative infinity, positive infinity. And then I'm going to select the x's right away for the end behavior. Those are never going to change for exponential. The first one will always be x to negative infinity. The last one will always be x to positive infinity. And then I have to determine where my y's are going. So on the left side, looking at this arrow is going down and down and down and down forever. So this y is going to negative infinity. And then on the right side, this one is evening out. You can kind of see that it like forms its own horizontal line. So it's evening out to that asymptote. So this one is approaching 6. And then again, you can see that one of them has the infinity sign, one of them has the asymptote. Okay. Then I'm going to do 2 of the log problems, which I can't tell which one I think is easier, but it might be the log ones. So I've got -2 log base 3 of x plus 4. So right away for these, I'm going to change the first couple. I know it's a log function, which means my asymptote is vertical, sorry, of x equals blank. To find that blank, you have to set the parentheses equal to 0 and solve for x. So if you set x plus 4 equal to 0 and you solve for x, you would get x equals -4. Okay, so -4 is our asymptote here. The range is always negative infinity, positive infinity. And then looking at the graph, I can see that it is decreasing. It's starting up and then working its way down. And my domain is always the asymptote, comma, infinity. So it's going to be -4 to infinity. And now I have to look at the end behavior. The left side, this x always has to go to the asymptote. So for the left side, x goes to the asymptote, and I have to figure out where y is going. So I'm going to look up here at my left arrow, and I can see that the left side here, this left arrow is pointing up and up and up. So it's going to go up to positive infinity. And the end behavior on the right side, x always goes to positive infinity, and you have to figure out where y is going. So looking at the right side arrow here, this one you can kind of see is not evening out. It never becomes horizontal. It's still going down. It's just going down really, really slowly. Okay, so this one's going down to negative infinity. Okay, and then the last one I'm going to do, sure. So I've got 2 times log base 2 of x plus 6. Okay, so this is a log function, which means there's a vertical asymptote of x equals something. There's no parentheses here. So from notes today, if you remember, I said if there's no parentheses, then your asymptote is 0. Okay, so we're going to put 0 in the box here. The range of a log problem is always negative infinity to positive infinity. And this one is increasing. So I'm starting down and I'm working my way to the top. So it's getting bigger, it's increasing. And the domain is the asymptote, comma, infinity. So 0, comma, infinity. The end behavior on the left side is as x goes to the asymptote, what's happening to y. So if I look at the left side arrow right here, it's kind of hard to see because it lines up with the axis, but that left arrow is pointing down. So it's going to go down forever, which is towards negative infinity. And the end behavior on the right side is as x goes to infinity. Okay, remember these two don't really change. This one is wherever the asymptote is. This one is positive infinity. And if I take a look at the right side arrow, this arrow is going to go up and up and up forever. So it's going to be y goes to infinity. Okay, please make sure you check the notes I posted again today. I added 2 of these diagrams. I totally forgot about them. So 2 diagrams go with this type of range. 2 diagrams go with this type of range.